Lights spark, hum, then a click comes through. Data's alive, whispering what's true. Buzzing wires sync in a neon groove. Welcome inside the Agentic Loop.
Welcome to Inside the Agentic Loop, the show where humans still get to talk, at least for now. I'm Christophe Briguet, your human host, and in this 15-minute deep dive series, we explore how AI agents are transforming the modern security operations center. Today we're kicking off episode 1, From Linear to Recursive, the SOC's Breaking Point. We'll unpack why the old workflow, SIEM, alerts, triage, response, is collapsing under its own weight. Too many alerts, not enough sleep, and far too many dashboards. And just so you know, our AI co-hosts insist on pronouncing SOC as SOC, because apparently SOC just sounds too human. But don't worry. They're here to explain how recursive loops and just-in-time context are going to fix everything. They've already written the script, and naturally, they'll be voicing most of it too. So grab your coffee or your favorite alert suppression rule, and join me as we go inside the Agentic Loop.
Today, we are really digging into something huge, facing security teams everywhere. The Security Operations Center, the SOC. For the analysts actually doing the work, well, the job has become almost impossible.
It really has. I mean, just think about the scale we're talking about, the sheer volume of data, the speed of threats. It's relentless. For years, the SOC was set up with this simple, linear flow, trying to keep up, triage everything. But what we're seeing now, very clearly, is that the architecture itself, that traditional way of doing things, it's hit a wall. It just can't scale anymore.
Right. So that's our mission for this deep dive, to figure out why that classic workflow is, frankly, falling apart. We need to get into the failure points, sure, but also look at the pretty radical shift happening now. This move towards agentic AI and recursive thinking, it's changing everything.
It's accurate. It's a fundamental shift, From that straight line, data in, SIEM alert, human triage, maybe run a playbook. Right. That worked, sort of, 20 years ago. But the sources we looked at are unanimous. That model is basically obsolete. The new approach, what some are calling the autonomous SOC, it's built differently. It's about these constant loops, iterating, refining itself.
Okay, let's unpack the failure first, because I think anyone listening who's spent time in SOC, they know this pain. Can you walk us through maybe the 3 biggest cracks in that old funnel-shaped workflow?
Oh yeah, the biggest one is probably the most obvious, right? That constant flood of alerts, that's the first systemic weakness.
Yeah.
Just noise overload. The old rules, they fire all the time, often without real context. So you have skilled analysts just drowning in false positives, spending like 80% of their day just saying, nope, not this one.
Yeah, 80%. And that just feeds straight into the second problem, doesn't it? Which feels even worse sometimes. Siloed investigations. Because they're always just trying to clear that immediate queue, each alert gets treated like it's completely separate.
Exactly. Like an island.
Check the box, move to the next one, you miss the connections. That compromised laptop over here, that weird cloud login over there, could be the same attacker, same campaign. But the linear process, it just doesn't give you the time or really the structure to connect those dots.
Precisely. And then the third critical flaw is, well, it's just too slow. The response time suffers hugely. All those manual steps, logging into tool after tool, trying to cross-reference things by hand, figuring out which playbook, if there's a playbook, it just stretches everything out. The time to detect, the time to actually do something about it. If you look at where analyst time goes in a traditional SOC, it's almost all eaten up by that manual tactical investigation grind.
And we did try to fix this, didn't we? Over the last, say, decade. We added ML for detection, graph tools in the SIM, AI assistance.
We did. But they were always sort of bolted on. Features added to steps in that same old linear process.
Right. They streamlined bits of a failing system, but they didn't fix the core problem.
That's the key thing. The real solution isn't just a better feature here or there. It's a completely different architecture. It's the recursive model. And this is where agentic AI really changes the game. It's not just another feature. The AI agent becomes the whole operating paradigm.
Okay, recursive. That sounds potentially complicated. What makes it recursive in practice? It's about breaking out of that step-by-step checklist. Is that the idea?
That's exactly it. Instead of fixed linear steps, you have these dynamic loops. The core capability of this agentic AI is it doesn't just look at the alert data it starts with. It uses that initial piece of information to ask new questions. And then this is the crucial part. It actively goes out, grabs new context, new data, and uses that to decide what to do next. It keeps looping, refining, until it reaches a confident verdict.
So it's pulling in just-in-time data, stuff that wasn't even in the original alert. Can you give us an example of that? Like, how does that looping work?
Okay, let's use your example. The impossible travel alert. Log in from New York, then boom, minutes later, London. A static playbook might just, I don't know, flight it, maybe send an email to the user. Stop there. A recursive agent sees that London IP and thinks, okay, need more context here. So it dynamically goes and checks, say, the ASN risk score for that London network block. Is it known for bad stuff? It checks the device compliance status. Is the laptop patched? Managed. Does it have the right security posture? And it instantly cross-references the user's login history across all their accounts. Has this happened before? Is there a pattern?
Okay, I see. It's not just looking at the IP address in isolation, it's instantly checking the trustworthiness of the whole network it came from, the state of the device. It's like building a mini case file on the fly for every alert.
Exactly right. The investigation unfolds dynamically. It pulls in evidence, weighs it, decides the next best query. It's less like following a fixed recipe and more like a skilled detective who can access every database instantly.
This seems to lead naturally into this concept you mentioned, verdict-first AI, and this framework, the verdict signal check, or VSC.
Right.
You said it reverses that old fire-first model that just creates all the noise. How does that work?
It's a fundamental shift in philosophy. Traditional systems basically assume an alert is guilty until a human proves it innocent, right? The VSCs flip that completely.
Right.
The idea is that a detection has to earn its way up. It needs to pass a series of structured, lightweight validation checks before it gets any serious attention.
Think of these VSCs as the bridge between just a raw signal and something you can actually trust and act on.
So it's like automating the first 5 minutes of what a good analyst would do, but doing it instantly at machine scale. That's a great way to put it. We can group these checks logically. You start with origin checks. Is the thing that triggered the alert inherently suspicious, like an unknown process or a connection from a known bad IP? Then you have impact checks. What could this actually do? Did it try to elevate privileges? Is it touching sensitive data? What's the potential blast radius?
Yeah.
And then there's meta-analysis, which is crucial for context, basically history. Have we seen this exact alert on this exact machine before? Did we dismiss it as an FP last week?
And the fourth one you mentioned, external context, that's where the recursion comes back in, pulling in that fresh threat intel.
Right, before a human even lays eyes on it. Let's make it concrete. Think about endpoint alerts. A VSC system can automatically see, okay, this is svcased.exe running from system 32. Known, good path, signed binary, it gets downscored instantly. But then it sees tempupdate.exe pop up in the user's downloads folder. And it has command line arguments like add encrypt. That gets massively escalated. The difference in signal strength is determined by the VSCs before it even hits a queue.
That really does sound like automating the basic pattern matching a Tier 1 analyst does. You shared a specific VSC example, the process prevalence check. How does that filter noise?
Yeah, it's simple, but really effective. When a new process hash shows up, the VSC basically asks, okay, how many other hosts in our environment have we seen this exact process on? If the answer is, say, more than 20, and it's signed by Microsoft or someone trusted, the VSC suppresses it. It's clearly normal activity for this environment. But if the answer is 1 or 2, then it gets escalated, because now it looks like it could be something unique, maybe malware starting to spread. It's about finding the anomaly efficiently.
And this gives you something the old way often lacked, explainability. You know why something got promoted.
Absolutely. Every alert that makes it through comes with a kind of audit trail. Which VSCs did it pass? Which did it fail? That's how you build analyst trust. They can see the logic.
Okay, but here's where it gets really interesting, I think, the human element. If the AI is doing all this heavy lifting with triage and validation, what happens to the analysts? You mentioned AI supervision, but AI supervision, that sounds a bit like corporate speak. What does it really mean? What's the risk if, say, a junior analyst pushes the wrong feedback button? How is their role genuinely elevated?
No, it's not just a title change. It's a necessary skill evolution. What we're actually seeing happen today is that the classic Tier 1 analyst role, the one focused purely on manual lookups and basic triage, that role is kind of dissolving. They're not spending their time doing those repetitive checks anymore. Instead, they're shifting towards more of a coordination role. They review the AI's synthesized case summaries, they validate the AI's reasoning, do the recursive loops make sense, and they focus their human expertise on the trickier cases, the ones that need judgment. The risk, to your point, is if they don't understand the AI's logic. They might accidentally dismiss a real threat because they disagree with the VSC without understanding it. Or maybe worse, waste valuable time escalating something the AI correctly flagged as low priority.
Okay, so if they need to guide it, how do they actually influence the system? Correct its mistakes, teach it? The sources mention this pyramid of influence, a kind of hierarchy for feedback.
Exactly. That pyramid maps out how much impact different types of analyst feedback have. At the very bottom, the lowest level of influence, you have passive classifications, just tagging an alert, true positive or false positive. It's useful for metrics, but doesn't immediately change how the AI behaves.
Okay, one step up.
That's contextual annotation. This is more powerful. It's not just false positive, it's why. FP because this is approved maintenance, or FP because this user always connects from 2 locations during travel. That specific note, that context, can be used to actually fine-tune the models or the VSC logic.
Getting more direct now.
Yep. Higher still are overrides and suppressions. This is where an analyst gives a strong signal. This specific alert signature on this group of servers, suppress it for the next month. Or the threshold for this VSC is too sensitive, raise it slightly. It directly modifies the system's behavior, its weights or thresholds, going forward.
And the peak of the pyramid, the highest influence.
That's detection, innovation, and logic changes. This is where the real value add from senior analysts comes in. They might identify a completely new attacker technique and propose a new VSC category to detect it. Or they might suggest a strategic change to how different VSCs are weighted together. This is about fundamentally improving the AI's brain. And based on this kind of hierarchy and the confidence from the VSCs, the agent decides how to act. Simple, high-confidence stuff gets handled in the autonomous tier, no human needed. Cases with borderline signals, maybe conflicting VSCs, fall into the collaborative tier, where analyst input is requested. And then you have the judgment tier. These are rare, maybe highly sensitive cases, think potential insider threats, where human oversight and ethical review are absolutely essential from the start.
All right, let's do the reality check. We're talking AI agents, recursion, large language models, LLMs obviously come to mind. Why can't we just point a giant LLM at the fire hose of security data and have it run the whole SOC?
Yeah, it's a tempting thought, but the main blockers are, honestly, economics and speed, at least for now. Running sophisticated LLMs on, the billions of events a large organization generates every day, the token costs are still just too high for that kind of mass ingestion and real-time detection. Even with models getting more efficient, it's generally the wrong tool for that specific job, high volume, super low latency classification.
So it's more of a hybrid approach then. If they're not processing the raw data stream, where do LLMs fit in? Where do they add value?
They're fantastic at what you might call creative acceleration. They shine a task that needs summarization, explanation, or generation, like taking a really complex investigation with tons of data points and summarizing it into 2 clear paragraphs for an executive. Perfect use case. Or explaining a complex attack chain in plain English.
Yeah.
Or even generating boilerplate code like regex or parsers for weird log formats. Think of them as the incredibly smart assistant, the translator, the summarizer, not the primary event processor pipeline.
Okay, so the LLMs handle the creative summarization translation tasks. And the more traditional ML, the classifiers, they still handle the heavy lifting at the front end, the real-time detection, anomaly detection at scale.
That's generally the most effective and economical balance right now. But that recursion we talked about, the agentic AI looping to get context, that has its own cost risk.
Right. If an agent gets stuck asking itself questions or querying external APIs over and over.
Exactly. Those agentic loops, if they're not properly controlled, could potentially lead to runaway costs, especially if they involve calls to expensive LLMs or threat intel APIs. You absolutely need guardrails.
An agent could brain through a budget pretty fast if it got stuck. So what are those essential guardrails? What engineering controls do you need?
You need a solid cost control framework baked in. 3 key things, usually. First, recursion depth limits. You basically tell the agent, you can only go, say, 5 steps deep in your reasoning loop before you have to stop and present what you have or escalate. Second, strict budget caps. Define clear limits on, for example, the number of tokens or API calls allowed per investigation or per user session. And third, you need fallback paths. If an agent hits its depth limit or its budget cap, what happens? It needs a safe way to revert, maybe to a simpler deterministic rule set, or just flag the case for immediate human review. It's about making it powerful but sustainable.
Okay, so let's try and wrap this up. We started with the old SOC model, noisy, slow, siloed, because it was stuck in that rigid linear process. And the shift is towards this autonomous SOC idea, recursive explainable intelligence, where AI agents use these verdict signal checks to validate threats before they swamp the humans.
I think the biggest takeaway really is that the SOC isn't being eliminated or automated way. It's being elevated. And this isn't some far-off future vision. We're seeing this change now, especially in how that entry-level analyst role is transforming. It's moving away from the repetitive manual tasks towards supervising the AI, steering its decisions, adding that crucial human judgment. The key skill becomes understanding why the AI reached a conclusion and knowing how to effectively guide it.
Which leaves us with a final thought for you, our listeners, to chew on. If this new crucial skill across all analyst tiers is really about the ability to influence the AI effectively, to provide the right feedback, the right overrides, then what kind of training data do organizations need? Is clean data enough? Or do they need noisy data, maybe even adversarial examples, to make sure the AI learns from the messy reality of operations and isn't just optimizing for simple metrics like precision or recall on a sterile test set? Because ultimately, the quality of that human feedback loop will determine how smart and how trustworthy these autonomous systems truly become.
It really is the ultimate feedback loop, isn't it?
We'll see you next time.